Hello everyone, my name is आरिफ शेख and I welcome you all to today's video. आज हम बात करने वाले कुछ algebraic techniques and methods जो कि commonly used होते हैं higher mathematics में, and these concepts will help you to understand equations more deeply and solve the complex problems more effectively. So without any further delay, let's dive into the video. So firstly, let us look at the topics that I'll cover today. Fundamental theorem of classical algebra, Descartes' rule of sign, Cardinal's method, and relation between roots and coefficients. So before going to a fundamental theorem of classical algebra, we have to know about algebraic equation. So it says that if f of x be a polynomial of degree n, then f of x equal to 0 is called an algebraic equation. Let us say f of x equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus an. And if a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus n equal to 0, then f of x is a algebraic equation. So now fundamental theorem of classical algebra. Every algebraic equation has a root, real or complex. So if f of x equal to x square plus 1 equal to 0, so it's an algebraic equation. The roots will be real or complex. So let us see, x square plus 1 equal to 0, so x square equal to minus 1, and x will be root over minus 1. As we know, root over minus 1 equal to I, so it will be plus minus I. So the roots will be plus I or minus I, which are complex. So now theorem 5.1.1, an algebraic equation of degree n has n roots and no more. For the equation we have taken just now, here the degree is n, so it should have n number of roots. For example, x square minus 5x plus 6 equal to 0. Here degree is 2. So if we solve it, we will get x equal to 3 and 2. So as you can see, here are two roots. So next, theorem 5.2.1. Here, point to be noted, in the equation, the coefficient should be real. For example, x square minus 2x plus 5 equal to 0. Here x square has 1 and x has minus 2 as coefficient, which are real. So if we solve it, we will get 1 plus minus 1 plus minus 2i. So we can write 1 plus 2i and 1 minus 2i, which are conjugate to each other. So let us solve a problem now. So here is a problem, x to the power 4 plus x square minus 2x plus 6 equal to 0, and one root is 1 plus I. So we can write 1 minus I is also a root of the equation. So now you can write x minus 1 minus I, and x minus 1 plus I is a factor of the equation. As we know, if 2 is a root, then we can write x minus 2 equal to 0. So here x minus 2 is a factor. So if we solve the factors, we will get x square minus 2x plus 2 is a factor. So now we have to divide the given equation with factor. So we will get x square plus 2x plus 3. So we will get the value of x as minus 1 plus minus root 2i. So the roots are minus 1 plus root 2i, minus 1 minus root 2i, 1 plus I, and 1 minus I. So let us solve another problem. Here the given equation is this and the roots are this. So we can write 2 minus I is also a root of the equation. So now we have to write the factor as x minus 2 plus I, and x minus 2 minus I is a factor of the equation. So if we solve it, we will get x square minus 4x plus 5 is a factor of the equation. So now we have to divide the given equation with the factor, and we will get the answer as x cube plus 1. So now we have to solve it. X cube plus 1 equal to 0. So we can write x plus 1 into x square minus x into 1 plus 1 square. So if we solve it, we will get x equal to minus 1, and the other value will be 1 plus minus root 3I by 2. Now discuss role of sign. So for positive roots we have to follow this, and for negative roots we have to follow this. So let us take an example. Let f of x equal to x square minus 4x minus 5 equal to 0, plus minus minus. So one change of sign, so one positive root. So for f of minus x, it will be x minus x square plus 4x plus 5 equal to 0. So minus plus plus. So one change of sign, so one negative root. So let us solve a problem. So here given equation is x to the power 4 minus 2x cube minus 1 equal to 0, and the change of sign is 1. So one positive real root. So we can write only one change in sign. Therefore cannot more than one positive root. Now replacing x by minus x. So f of minus x equal to minus x to the power 4 plus 2x cube plus 1 equal to 0. So minus plus plus. So as we can see, one change of sign, so gives only one sign change. Therefore the equation cannot have more than one negative root. So now you can write, since given equation is biquadratic, therefore it should have 4 roots. Therefore there must be 2 imaginary roots. Some more examples here. So 1, f of x equal to x to the power 4 plus 2x cube plus 3x square plus 4x minus 5 equal to 0. So plus 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 minus. So one change of sign, so one positive root. So next one is f of minus x, x to the power 4 minus 2x cube minus 3x square plus 4x minus 5 equal to 0. Plus minus minus plus minus. So here 3 change of sign, so 3 negative roots. Now Cardan's method. So point to be noted, here x square term should not be present in the equation, and we have to use x equal to u plus v. If we cube both sides, then we will get x cube minus 3uvx minus u cube plus v cube equal to 0. So then we just have to compare both the equation, and note that omega and omega square are also used in the equation. Here omega and omega square are complex cube roots of unity. As we know, a cube must have 3 roots. So now let us solve a problem. So x cube minus 8x minus 35 equal to 0. Let x equal to u plus v, so we can put this. Now comparing both the equations, we will get minus 3uv equal to minus 18, u equal to 6 by v, and minus u cube plus v cube equal to minus 35. So we will get u cube plus v cube equal to 35, and if we put the value of u here, we will get this. Now let y equal to v cube, so we will get y square minus 35y plus 6 cube equal to 0. If we solve it, we will get 27 and 8. So if y equal to 27, v cube will be 27 2, so v will be 3 omega and 3 omega square. As we know, a cube must have 3 roots. So from u equal to 6 by v, we can write this. So the value of u will be 2 omega square and 2 omega. Now x equal to u plus v, so it will be like 2 plus 3, 2 omega square plus 3 omega, 2 omega plus 3 omega square, and if we put the values of omega and omega square, we will get the values of x as 5 minus 5 plus I root 3 by 2 and minus 5 minus I root 3 by 2. So this is for today, guys. Thank you for watching, and I'm Arif Sheikh signing off this side. See you.